Excuse me. Okay, good evening. I don't think the camera is going to be working for us tonight. Not really looking at restarting the machine though. So unless we get any major objections, I'm just going to be an anonymous face on stream tonight. Okay. More importantly, I'm hoping everyone's had a chance to have a quick look at the instructions that I gave for getting started. If not, !Friday in the chat will give them to you. So we have a couple of things. I'm now looking at this. So a couple of things to download. So if we go to this one, which is the .NET Core website, we are looking at downloading .NET Core SDK. It'll ask us to run it. I don't need to because I already have it. And that will run. It'll install as normal. It'll run. Anyone with Visual Studio on doesn't need it. Thank you, Minxie Rose. We'll have a look at the homework in a moment. For Visual Studio Code, I will install this live because I'm hoping I've managed to get rid of it well enough to do this. So again, that was the other link. It'll detect the operating system you're on. I'm on Windows. It's asking what I want to do with the setup. I'll click run. And in theory, we should have Visual Studio Code running on here very soon. When we come to one of the breaks, I'm sure I will be able to sort out some settings for why we don't have camera. Again, apologies for that. So we'll install this, accept the agreement because everyone reads these agreements. Stick it somewhere like, let's say, there. The add to path thing is interesting. You have to do a restart for that, but again, everything is pretty much fine for the defaults. So we'll install that. What I'm thinking of is I'm going to try and diagnose this camera issue quickly. Get us back onto the prerequisite screen and be able to talk to you from there. I clicked that too soon, didn't I? Hang on. So from here I can still talk to you. Hopefully you can still hear me. I'm going to have a go. By the way, when it says at the end to launch Visual Studio Code, let it do so. We're just going to have a quick chat to make sure that everyone catches up. So just have a look. Darix can hear and see, thank you. Will Bevan, just happened to see the stream is starting now, so you thought you'd pop in to say nice idea and you hope it goes well. Thank you very much. This will be available on video on demand for 14 days with Twitch, so no worries there either. It's you can have a look whenever. If you join our Discord, which I'm sure someone can post the link into chat for you, then we can then you can always come and get some assistance or whatever from us. At the moment, I am just going to have a quick look at why my camera is misbehaving. Good afternoon, EdgarDev86. Please, if everyone would welcome EdgarDev86 into chat, please and thank you. So yeah, that's all we need there. I'm just giving everyone instructions on the screen at the moment and trying to delay a little bit to make sure that everyone gets to catch up. If you've got everything installed, please let me know. I'm just doing a little bit of diagnosis because everything's just decided to die on me. We're getting issues here. Have I got to reinstall a driver by any chance? So where's the solution to this? Okay, so it might be a quick driver problem. Let me go into Device Manager. Apologies, this is normally a little bit more professional than this. I'm not saying professional, but normally a little closer to the truth. I'm getting no real issues. Let's do a force update on that driver. Derek's 12, you're installed. Excellent. Do you have a reasonably dark looking window up? Because that looks like Visual Studio Code. Check for updates. I don't want to do this. No, we're not checking for updates. We'll uninstall the device and we'll reinstall it. Easy way. Edgar Dev is fine, thanks. Ready to learn F#? No, I'm not restarting my computer right now. This is being silly to me. It looks like to sort this out, I'm going to have to do a reboot. So, if no one minds, I'm going to do this cameraless today. I think we've stalled enough. So we're in a programming tab. We're in Visual Studio Code. Now, just for a quick tour, we have around these parts. Oh wow! No, my machine I thought had frozen. Yeah, I gotta love tech issues on stream. That's more like it. So up here we have sort of areas to go, so we can have a look at the files, we can do a search. Source control we're not bothering with in this stream, debug probably won't, and extensions we will. It's installing the C# extension by default. We will need that one. In fact, if we zoom back in, let's go for another extension that we will need. There's a wonderful extension called Ionide. Ionide F#. And about there, it will be a little install button. So if we go for that, this machine is really struggling. Just so that everyone knows, I am hoping to have a new computer in the next couple of months. So this should become less of an issue. I know we've had a couple of tech issues over the last couple of streams. I am hoping to get rid of those soon. So that's installing. Now, this stream, just to set expectations, we are looking at the very beginnings of F#. Once that's installed, by the way, little reload button reloads the window. You're getting none of this, Minxie Rose. Okay. Do you have Visual Studio Code open? Also, if everyone else is getting this extension installed, that would be lovely. I'm just waiting to hear. Yeah. Have you found this little button here, Minxie Rose? This extensions button. I've got to love stream delay. Normally I'd be talking more, but I really do want to make sure that everybody is with us for this stream. You have now. So if you search for Ionide in that box, you'll see one there that says Ionide-F#, and there'll be a little install button there. Have you managed to get that to install? Hang on, let me get back to there. So right at the top, pressed it. Cool. So in theory, we should have that installed now. And if we delete everything in that search, we'll get, in under enabled, we'll have a C# one that we're not bothering updating, and the Ionide F# one, which is all fine. Can everyone please let me know once we're in this state, because then we can actually start with some programming. And I think I might have heard the door. I'm sure Minxie Rose will tell me if it was the door or if it was a washing machine banging or anything else, because she is actually just in the kitchen kind of. I was pointing at the room, but obviously you can't see. Right, Edgar Dev is ready. Minxie Rose, are you ready? Derek's 12, are we all ready? Anyone who's lurking, please let me know. Are we all ready? I've just switched across to that. I didn't need that on screen anymore. DirectX 12 is ready. This is good news. We're getting people ready. Ancient Coder is ready. Bang was the wind. What else are you downloading? Minxie Rose, I know that you already have the .NET Core SDK on because I installed it on your machine for you as part of Visual Studio itself. So that is absolutely fine. So next up, let's have a look at actually doing something in here. Let me go. This version of Visual Studio Code is exactly as it is out of the box, so I'm not getting any niceties here. So everyone's now ready. So if we go File, New File, and then at the bottom right down here, there are some nice options in a wonderful fetching purple. One of these is called, it has plain text, and if you hover over it, it says Select Language Mode. Now we're going to be using F#, so let's click on Select Language Mode, or click on the plain text, and then, it doesn't appear there. We will see a good list up here of languages to go for. And if you hadn't already guessed it, F# might not be a bad idea at this point. This editor works in so many different languages. We've added F# to it. So if you click F#, it goes back normal. And then down here we're getting, consider using the .NET Core language services by setting, do you know, I'm not going to bother with that at all. Yeah, let's not do anything. Let's see what happens. Minxie Rose, can we go back to show you where to pick a language? We certainly can. On the purple bar at the bottom, near the happy smiley face, is something that will say for you, plain text. It's where I'm hovering my mouse cursor now. If you can click on that, then up at the top, you will get you'll get this list here. And then we're clicking F#. By the way, to anyone who's just joined us, welcome into chat. We're not going to be going particularly fast today. We are just looking at getting F# running and getting it running well rather than going into advanced things. So I think we should now all be ready for some F# and to actually do some programming. So what I'm going to do is something you don't need to, but I want to make this really big, the text for you. So I'm going to use Control Comma. In search settings, I'm going to go to font size. And instead of it being a 16 pixel font, I'm going to probably double that or even go bigger. I'm going to go 48. I wouldn't do that normally, but hopefully now you'll be able to see my screen much, much, much better and save me hours of zooming around. So for our very, very first bit of F# at all we have to do is the classic, let's do hello world. F# has a function in it called printfn, so print F for formatted string, N for new line. Visual Studio Code has been really nice and giving us options. So after that, just a quick space, and in double quotes, anything you like. And if we highlight that whole line and press, I believe, Alt-Enter, then it runs that for us in F# Interactive. which I don't know if I can zoom on. But there it is. It's given us Hello World back along with something underneath it that we'll learn to understand soon. But we've got Hello World. So we're now there. We've got a program running. So what did we just actually do? Well, if I try and use a new little bit of tech, which, believe me, is far, far lower class than you could ever think, I'm going to have a go at trying to draw on that screen. And there we go. Okay, got nothing. Let's go back. So, did you type in exactly what I have there? printfn hello world. And then did you press Alt Enter? So it's just a case of typing that in, pressing Alt Enter, and we should, under here, somewhere, get Hello World. If you can let me know if you've managed to get that to happen. Yeah, got nothing coming up. Do you even does it look like this, or have you got nothing down here at all? If you've got nothing down there at all, control single quote, as in the key with an at on a UK keyboard, just above the slash and question mark keys, should bring this this window up. Is that happening or not? Also, if anyone else who's in chat, please feel free to help people out and see what we get. Try and, you know, if there are people that do know F#, please, 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 you're more than welcome. Yes, you've got that now. Excellent. So if we go and we draw on the screen, because it's probably worth explaining what we've actually done there. Down sort of around here, this is all F# interactive stuff. That was horrible. Can I undo that quickly? Yeah. Let me get that drawn a little bit better. So that stuff we're not bothered with. That's all what someone else has done for us. That's the command we wrote. That command there. That hello world there is what it outputted, and then there's something underneath it that we don't like. You don't have that bit. Mingsy Rose, now that you've got this area up down here, is it worth you highlighting this bit again and holding Alt and pressing Enter? So hold the Alt key, press the Enter key. So again, highlighting that block of text there. Whoa, I really can't draw. This is going to make this interesting. Even if that bit down there hasn't come up, which would be a shame, does it say down here Microsoft F# Interactive version whatever? Or are we getting errors? It's at this point I really wish I could see your guys' screens. Unfortunately I can't. Also, while we're here, for people with full Visual Studio installed, before I go into this, let me just redo this example in Visual Studio itself. Just in case. We can go to Visual Studio by opening that up. We can then... you're in PowerShell, you're not in F# Interactive. Okay, that's interesting. Have you tried highlighting... Did you manage to get that Ironide extension installed? There we are. Darix is here with some help as well. Thank you, Darix. While the other thing is, did you restart Visual Studio Code after installing that Ironide? They are pretty common issues. For people who have full Visual Studio installed, if you wish to follow along in full Visual Studio, you probably know how to use it reasonably well. The only thing I will show you is that you can open F# Interactive by using the thing I love most, that quick launch window there. F# Interactive, or Control-Alt-F. This is only for people with full Visual Studio installed. Minxie Rose, that's not a bad idea, to be fair, because I know you've got that installed and it working. And again, you will see down here F# Interactive like that. That works really well. So whenever I'm using Alt-Enter to move stuff to F# Interactive, if you just type it into F# Interactive from Visual Studio, that will also work. Remember the double semicolon. So for the example we've just done, it will be print fn space and in double quotes hello world. Then the double semicolon, press enter, and it will work. What stuff is it doing, Minxie Rose? I'm just very conscious that we do need, realistically, to go into what we've just done there if we can get a setup working for everyone reasonably quickly. Is there anybody else in chat having any problem with any of the setup? Okay, updating cache and random bits. Just remember, Minxie Rose, once you get into Visual Studio, launch F# Interactive, or press Control and Alt and then press F, which will bring this F# Interactive window up. And I think everything that we do tonight, we should be able to do in there. Because I've asked people to download Visual Studio Code. I know not everyone wants to install all of this. I'm going to move across and do most of what we're doing in Visual Studio Code. But this window down here is exactly the same window. It's just that this one's got a little bit of nice color coding, which will make life easier. If you can't follow along, don't worry. Just watch the stream. You can follow along again on video on demand once things actually work properly. I think we're going to take more breaks in this stream than we normally do, because I want everyone to have a chance to catch up, to look at things, and to try and do troubleshooting. But I think right now we ought to look at what we've actually done there. I mentioned that printfn is a function. So if I do that, that is a function. We will look at writing our own in a second. The space after it, and then anything that comes after that space, is called either an argument or a parameter. These are things that are put into that function. So printfn, you can give it any text you want. You could give it, instead of hello world, say something like boo. And by doing so, you would just put boo in those quotes there. Then down here, instead of that being hello world, it would be boo. If a function takes multiple parameters, you separate them by spaces. So let's have an example. Or Sam loves butts. That would also work, Minxie Rose. Probably not the best thing to put though. I mean, let's face it, we're not on Go 8-bit at the moment. So with that, we have, and by the way, if anyone can hear a bit of banging, that is the washing machine on the go. Like I say, this is highly, highly unprofessional tonight. So let's have a look at writing our own function. Above there, let's write a function that adds two numbers. And it's let add AB equal A plus B. And at this point, we can do printfn. We'll do something different than hello world. A %d, and then in brackets add 59. And that should give us a 14. If we highlight all of that and press Alt Enter, or if you type that into F# Interactive, you will get 14. Actually, Minxie Rose, do you still have Visual Studio Code open? I am just wondering if... Oh no, I can't think of a right-click way. No, sorry, ignore that. I'm just trying to make this work for people in Visual Studio Code easier. So has everyone managed to get a 14 out of this? For those using the for those using F# Interactive directly or through Visual Studio, that is essentially what we're doing. So let add AB equal A plus B, printfn %d, add 59 and 2 semicolons. And you should get 14 and 2 bits of what look like gibberish at the moment. Believe me, they're not gibberish, they can be really, really helpful. But for now, let's call them gibberish. Because gibberish works, and we understand that. So, let's have a look at two things. One, in fact, let me go into drawery mode again. Now that I've got the tool, I'm using it. So we said that printfn takes a string or any text between quotes. However, this time we've got %d. What does %d mean? Well, % and anything means that it's a format specifier. So this is replace this with something else. D is for a decimal number. There's also S and a few others. But it's in blue here to help us out. So that %d there is a replace with a number. And given that we've got 1%d, then printfn expects one thing after it. So we put the add 59 in brackets. If we took the brackets out, then what would happen is printfn would see %d as an argument, add as the next, 5 as the next, and 9 as the next. But by doing that, and using those brackets, it says evaluate whatever's inside the brackets, and that's an argument. So it's saying evaluate add 5, 9. Well, we can do that. We have add AB there. So let's say for now that with add AB, A equals 5, B equals 9. Because that 5 goes into that slot, that 9 goes into that slot. And what does the function tell us to do? It tells us to do A plus B. 5 plus 9. Which is reasonably simple to work out. We get 14. So it's saying printfn, that %d there, and then 14. So that all comes out as 14, which is a decimal number. And that's the first decimal number in that list. So it drops it there. Does any of that make sense to everybody? Does any of that make sense? Or am I going too fast? If you don't respond, I'm going to assume that it makes sense. By the way, feel free to whisper me if you don't want to say publicly that it doesn't make sense. I won't call you out by name, but I would like to explain things slower if needs be. So what we've got by doing that, yeah, that makes sense. So what we've got there is we've got a simple function that we wrote. Let's have a look at something else. What's appeared here is that same gibberish that appeared, well, very similar gibberish, down here, which is add colon a colon int arrow b colon and arrow int. So that says int, 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 and it's got arrows between them. Yeah, that's saying that we've got a function that takes an int, and then it goes to another function that takes an int, which then spits out an int. Now, funnily enough, I've put brackets there. We could say that we've got a function that takes one int. So that looks like a function that takes one int and returns a function that takes one int to spit out an int. We could say that we've got a function here that takes an int and spits out an int, which is the input to another function that spits out an int. So these brackets really do not matter. Doesn't matter which order we claim we're doing this in. But hang on, we don't have a function that takes something and returns another function that takes something to return an int. We have a function that takes two parameters. Actually, that's just a convenience in F#. All functions are single parameter functions in F#. All functions take something, return something. They don't take multiple things, they take one thing and one thing only. For unlike in Monty Python, 1 is the number of the counting, and the counting will remain at 1. So what does this function actually mean? Well, let's change that %d to a %a to say, print me anything you're given. And let's forget to give it that 9. Let's say we're going to give it just add 5. So what we're saying in theory at this point, well, no, let's run it. And what it's done is it's printed something really, really weird. Thank you, Derek12. Feel free to, again, join our Discord if you need anything to help at all. We're a right friendly bunch in there. Also, you know, follow me on Twitter. Come and have a look at the GitHub that we have going. All the rest of it. I think I even have a website somewhere. But yeah, if everyone could say good night in the chat to Derek's12, please and thank you. So what's this done? We've added 5, but we've not passed the second parameter. Now, for people who know something like C#, you would expect an error. You'd expect that to go bang. And it hasn't. What it's done is printed as the F# textual representation of a function. So that is a function. And then again, we defined add and we defined it to be unit. Unit is a nothing type. Unit can have that value and that value only. So don't kind of get hung up on that. So what did we actually do? Well, let me rewrite this add function in the way that F# actually understands it. So let's call it add tick. Just single quote. You're allowed to do this in F#. And we'll just pass it an A. And then in there, in the equals, we need the tab. By the way, F# is white space sensitive. So I'll write this function and we'll go through what we're doing here. So we're then going to let add again b equals a plus b. So if we now use add tick, oh, and I think we need to call add again. I might have messed this up because that's a function. No, I can't. I can do that, I think. Oh no, I have to return add again, don't I? So what we've done is we've defined a function that takes a number, and that creates a function that takes another number and spits out that function. And again, that's defined as taking an int, going to an int, and going to another int. Those functions on lines 1 and 3 are identical essentially. But we've got more to talk about now, and by the way, to prove that this one works exactly the same way, let's put that 9 back in, down here. Let's change that from the %a to the %d again. Highlight just that bit, because we're not calling that function anymore. Alt-Enter gets us into F# Interactive, and again, we get the result that we're looking for. We get 14. So at this point, again, we're going to have a look before I break for questions quickly at a screen sketch. What can we deduce from this? Well, we now know that works there. In this instance, this is a function add tick that takes an integer parameter there and returns this function. So the function actually, is that, and then it returns it there. So it returns that function that takes an int and spits out another int. Int, for the sake of an argument here, is whole number. That's all int is. Yes, there's a size limit to it as well, but that's all well and good. So we now have another function, let add again b equal a plus b. Hang on, where did that a come from? Well, that a actually gets closed over. It gets captured. It gets slightly kidnapped, but that's a little bit mean to suggest. That has access to everything there. So that a comes from there. That b just comes from there. And that function gets returned. So, add tick 59 calls the function originally with a 5. So at that point, add again becomes equal to 5 plus b. So what's returned from that function is a function that goes 5 plus something. We don't know what yet, but we've pulled the drawstring back. And then remember, parameters to functions are separated by spaces, so that's one function. Then passed into that is that 9. Now that 9 goes there to be that b. That b, then that 9 goes in there. So we've just filled our A slot and our B slot. Or variable if you really want to be technical about it. So we've got an A slot and a B slot filled. We've got everything we need. So this can spit out 14 with that included. So, does everyone get that? I'm going to leave this up for a second or two and invite questions. These are immutable, asks Minxie Rose. Yes, they are. Immutability is a topic we will get onto in a bit. But yes, these are immutable. Actually, we're going to do it slightly the other way around. We will get onto mutability a lot later, because for a long time we're not going to need anything to be mutable. In fact, let's do immutability next. I'm not going to show you how to make something mutable, because for a long time I don't think we need to. To give everyone on here an idea, we've built a very primitive mobile application in F# and the tests, and up until the last stream doing that, we hadn't touched immutability, and we still only have immutability in one mutability. Sorry, we only have one mutable thing in one test, because there isn't a reasonable way to get around it that we can think of yet. Emphasis on the word yet. So, does everybody understand what we've just done there? We've created a function that takes one parameter, spits out another function that takes one parameter, that spits out a number. There is a question that I would like to ask though. How did it know we were only going to be dealing with whole numbers? What happened if we use something like 0.2 and 1.5? Why is it telling us that we can only use whole numbers? Because I can add 0.2 and 1.5 and I can get 1.7. And hopefully my maths is not that terrible. So let's look at the answer to that. What F# does is looks at the simplest case it can to start with. And we have passed 5 and 9 to F#, and they're both whole numbers. So F# has determined that we are working with whole numbers. What happens if we do pass? What did I say? I said 0.7 and 1.5. And now it's suggested that this function is actually a float to float to float. I passed 0.2 and 1.5. I do apologise. See if anyone in chat caught that. No, not yet. Go on, chat. If you can spot something I'm doing wrong, if you can spot something I'm missing, please, please, please tell me. Let's see if you guys can catch things that I miss, because that would just be fun. And it'd show that you're all paying attention. So, we've got float, float, float up there. And if we run this again, it's crying, because I can't select text properly. It's not crying? Oh yes, that %d now doesn't work. I've made a mistake here that we haven't covered yet. That D doesn't work for floating point values. It only works for, let me have a look. By the looks of it, it only works for types of number that are whole numbers. This is a question that came up in our normal stream of %A seems to work for everything. So why don't we use it? And this is one of those cases. Assuming that I had only intended whole numbers to be used there, F# would have caught it. If we use %A, it'll let me do anything I want. And there we go. And Minxie Rose, top of the class on this one. Would %F be better? I would suggest that %F should be better. Because %F... Oh, no, I didn't mean to save that. %F still works for floating point numbers, and it gives us 1.7 and rook of zeros. So it's suggested its own format. The reason %F would be better is because if I'd suddenly returned something that's not a float, we would all of a sudden get an error in the compiler. If we used %A instead of %F, and this add function changed and became silly, we wouldn't catch that until we run the program. So so one big thing about F# as a programming language, it likes to be strict in its compiler. So when we go from when we compile it or interpret it, if it succeeds in that, then it's already passed a whole host of tests. Incidentally, we should back up a moment and talk about programs, because I believe we've got some people in here who haven't programmed before. So let's go. I don't want that. Let's have a look at what happens. We have some code. This is what we've written. You and I understand this. Well, I understand it. You will understand it soon. This is something like let a equal ... Yep, that's standard F#. That then goes into a preprocessor that, as the F#, it's built into the compiler, but that's the preprocessor. That does things like gets rid of any compiler directives. So, #if, things that we don't need to worry about. So we don't really do anything in there, and the #if we don't worry about. So let's not bother with that for now. Then it goes to the compiler, which spits out things that look like, LDA, whatever. Essentially an intermediate language called, I think still, either MSIL or CIL. It's either Microsoft Intermediate Language or Common Intermediate Language. I know it's one or the other. I know it's changed names and it has been both in the past. They are what run on the .NET Virtual Machine. Then from the compiler, we go to something called the linker. If you remember, we said at the start, F# has a built-in function that we're using called print fn. That has to be defined somewhere. That is in the standard library, which is linked in to our program. So our program doesn't just have what we want in it, but then there's a whole library of functions and other bits and bobs that we are given for free by F#. That's all linked in at that stage. Also, if we write a program over multiple files, if we go into that kind of thing, the linker again looks at that. So that's a very basic and probably slightly incorrect overview of the work, of how compilation works. And then it comes out with either an exe, a DLL, a .so, possibly on Linux, whatever. But that comes out with your compiled, runnable code that you just run. So Minx Heroes, that is jolly good of them. Without that kind of thing, most programming languages would be nearly useless. So again, are there any questions about this? Minx Heroes, good point. It's a basic input-output process. And actually, what you've just hit on there, Minx Heroes, possibly by accident, is the crux of functional programming, which is the style that we're learning here. It is all basic input-output. There's very, very little in the way of, changing things for the sake of changing them. To give an example, let's actually play with mutability. Let's have an error. So if I do, by the way, don't necessarily do this because it will go wrong, it will error. Let number equal 5. And then somewhere else in our code, we want to set number equal to 9. Now, I would assert that should fail. If I try and run that, it hasn't failed, it's done something different. Let number equals 5 has done what we thought. Number comes out as 5. And then number equals 9. That isn't setting number equal to 9. That's not even trying to set number equal to 9. That's asking, does number equal 9? In F# we do not use double equals. We do not need to. And the val it colon bool equals false. It is the last thing that it evaluates, which is number equals 9. That is false. That's not true. So how do we set number equal to 9? Well, okay, we set it equal to 5 by using let in front of it. So let's try that let. Let's try that again. And it's gone bang. It didn't like me doing that. And if we have a look at the error, it said duplicate definition of value number. What that error is telling us is you've already looked at the number, you've already set that thing number to something. So down here, you're not allowed to do it again. You've already defined that number exists. Okay, how else could we try and make number equal 9? Well, let's use the F# assignment operator. Oh, right, at this point, do excuse me for a second because something has changed that shouldn't have done. And I am going to quickly change back to stop you having an issue. Right, number setting to 9. So we're changing that number to 9. That is the assignment operator. So number at the end of this should be 9. No, it goes bang. And it gives us a very helpful error message. Error, this value is not mutable. Consider using the mutable keyword. For example, let mutable number equal expression. This is a bad thing. This needs using sparingly. If we put the word mutable, if I learn how to spell as well, then this will work. And finally, as I suggested, that has worked. Number has come out as 9, not 5. And that val it's unit whatever. But number is now an int equals 9. I have only shown you this because this is something that people coming from C# or other languages will probably run into. This is something that I do not like using in F#. F# forces you to put that keyword mutable there and says if you do not put that keyword mutable there, then you cannot change that value. Bad. Naughty. We do not do that. So how do you do any computation at all? Well, let's go back up. As we saw up here, we applied functions. We used the result of them. What does that mean? Well, it means that add 0.2 and 1.5, let's say instead of that, we'll let small equal 0.2, let large equal 1.5. Hi, I can't pronounce. I'm sorry, I can't pronounce your name. Delave Gasway. I'm sorry. I've probably butchered that punctuation. Please let me know the appropriate punctuation if you can. Is F# object oriented? F# has object oriented abilities. It is what's known as a De La Vega, Sweden. Ah, thank you. F# has object-oriented properties. It is described by Microsoft as functional first. So we tend to try and use it as a functional programming language, but to interoperate with the rest of .NET, there are features that are object-oriented, and it is very capable of it. I'm trying to teach the functional side as much as possible. because I think that's where F# gets its real benefits. A big part of that is immutability, which is something we're going into. So we have small as 0.2 and large as 1.5. Add small, large. Now, in C#, in any other language, well, let me ask a question. What are small and large after calling that add tick function? Have I changed them? I really should have some Jeopardy music or something here for when I'm letting everyone think. I should be going. I'm going to stop that. That's probably going to drop my viewer count to 0 doing that. So in chat, this is interactive. They're the same. Yes, Minxie Rose, they are exactly the same. They do not change. No matter what that function is, small and large cannot change within that function. That function cannot edit that value nor that value. We can't edit those values either. They are the same. So, if I do that, can we guarantee that every time we call add with small and large, we get the same answer back? The question is, can we guarantee it without knowing what that is and what that does? Is it going to give us the same answer every time? And if so, can we guarantee it? Well, let's at least have a run of it. And as we can see, it comes out with 1.7 every time down there. Now, in a language that's object-oriented and has mutability more than OO, because OO doesn't matter here, in a language where mutability is default, I could not guarantee that those three things are going to be the same. I could not tell you with an absolute certainty that they would be the same. In F#, I can. In F#, I can't say, I don't know, let's make A equal something like 4.0 after that stream. Well, before doing that adding. I couldn't do it. I will try. I will show you what will happen. So let's go into here and have another go. And it's told me no, because it's told me that it's not a mutable value. So let's see what happens if I pass A. Can I pass A mutably? Can I do something like this? Whoa, keyboard's misbehaving. Okay, let me just quickly fix that. Occasionally, I don't know, I think it's firmware in this. Could I pass a mutable A there? I don't know, will this work? What error will I get? It's just not going to work. I don't know of a way in F# where I can tell where a function can mutate its inputs. And I hope that there isn't one. That's a feature I hope doesn't exist. So to recap, we can't do that. We cannot change that value. So, we now know that we can call that add function with those two numbers anytime we like. And we will get anything, we will get the same thing every time. So we've learned how to add numbers, which is that. We've learned how to write a function. We've learned how to spit something out to the screen, and that we can use format specifiers. We've also learned that all functions in F# are single parameter functions. And that actually what we're doing here is constructing a function within a function. And this can work again. I mean, we could have a C there, becomes A plus B plus C, and then we would have let add yet again C equal, well, A plus B plus C. And that would return that. So add again would have to return add yet again, which would then return add again. So calling that function with just one parameter. Well, let's go into drawing mode. Go to the sketch pad and no, let's not go to the sketch pad. Let's go to the screen sketch. So if we call add A, then what we get is that function returned, because that's the final line. That function, if we call with a B, so add take A, spits out add again. Yeah? And then if I can change colours, let's change to a brightish yellow. So add again B, that returns that. So add A goes to add again. Add again with an argument, so add again of B will spit out something completely different. That will spit out add yet again. Excuse my handwriting. And if we call add yet again with a value C, so add yet again C. No, go on, I'll write it. Add yet again C, spits out A plus B plus C. So it spits out that C that went in there. We go back to the yellow. The B it gets from there. And the A it gets from there. So it literally spits out A plus B plus C. Wow, that's a lot of colour changes. Does that make sense to everybody? Question, I haven't defined C. Is that deliberate? I have defined C. C was defined there. The definition of C is a value that I can pump into add yet again. So C would be whatever type that this is. Up here, I'm not entirely sure whether that's just showing tick A to tick B. I think it's because we haven't called add with all of those parameters, so it doesn't know exactly what it's working with. Type inference isn't that clever. If I called add tick with 1, 2, 3, I suggest that that would say something like int to int to int to int, because it's that'd be your A, B, C, and result. let's find out, shall we? Let's see if that's what it does. So instead of doing that lot, let's go back to just doing add tick, and let's say 1, 2, 3. And that for I was hoping someone would catch this in the chat. There needs to be an equal there. That equal is important. I did not put it in. It cried. So now it is saying int to int to int to int. So that's A, B, C, and the result. So that'd be 1 goes in that first one, 2 in that second one, 3 in that third one, spits out the result. So add 1 is add again, which takes 2, which is add yet again, which takes 3, remembers what the functions before it took, and does the calculation. And that, I assert, comes out with 1 plus 2 plus 3, 6. And, oh, again, format specifiers, people. We've changed add tick from being floating point to integer. We need to change our format specifier to match. My assertion was incorrect. But if we do that now, that's 6. What you'll notice I've done there is written a lot of code. To add 3 numbers, I've had to write all that code. Which is why F# is really nice and doesn't make us define all the functions ourselves. It defines them for us. And instead of us saying we know that this is a function that spits out a function that spits out a function that spits out an answer, F# calls this partial application, or there is currying. The two concepts are very, very, very closely related. And the idea is that we don't have to provide all of those parameters at once. So let me show that. Let's get rid of this, because this we now understand to be... See, before I get rid of this, does anyone have any questions as to why this line up here and this is equivalent? If anyone's got any questions on that, please let me know as fast as possible, and I will try and answer them as quick as I can and as thoroughly as I can. Assuming that my chat works properly. Let's go back to the dashboard on here. No questions there. Anybody else? Any questions off anybody? Please do shout up in chat. Anyone who's got experience in F# or who hasn't got experience in F#, whichever, please shout up in chat. I'd like to get to know every one of you. I mean, Della Vega, I'm sorry I forgot to ask. Obviously, welcome to the stream. Where you say Sweden, do you have any programming experience at all? Do you know anything about F#? What are you looking to learn? What are you looking to get out of this stream? This really is about you guys as much as it's about me. You know, it's no good me just banging on about something that people don't know. So, I've given that a moment or two for questions. So now, I think we get the idea that instead of having to write all of this nonsense, we can just write that. So, let's say we want a function that adds 2 numbers to 3. For some bizarre reason, we want to add 3 to a few things. And we don't want to rewrite things. We've got a function that adds 3 numbers. We just want a function that adds 2 numbers to the number 3. So let's write one. Let's say add 2, 3. This can be anything you like. In fact, it could be, for all F# cares, it could be Bob. But, let add 2, 3. Makes more sense, I would suggest, considering that's what we're doing. add to 3, we'll take two numbers that we're calling A and B. And then we're going to call add 3AB. So what we now have is a function add to 3 of A and B that calls add of 3, A and B. So by doing so, we've what's called partially applied add. We've given it one of the things it needs. At this point, we can go add to 3, 4, 5. At that point, we've given it everything it wants. We'd need to get rid of C. Why do we need to get rid of C? Actually, let's make this clearer. Let's call that X and that Y. Let's make this completely different. So we've got let add to 3 xy equals add 3 xy. And then that works, I say. And it does. So let's go into depth about why this works, and then I'm going to do something that you'll see a lot more often in functional programming, because I think we're getting a little bit of confusion. So into screen sketch mode we go. Right, so let add ABC. We're all happy with that function there, aren't we? Well, let's have a look at add to 3xy. We're happy with the idea that that x goes there, that y gets dropped into there. But of course what we're doing is we're calling add 3xy. So that add means we're calling that function. Then the first parameter that we're passing in is that number 3. That drops into that A. The x that we're passing in next drops into that B. And the y that we're passing in there drops into C. So what we're getting is, let me change colour here. We're actually getting add 3 x, y, which means that that is actually 3 plus x plus y. At this point, we're going add to 3, 4, 5, which means it's calling add 3 from that part. Then we are passing in, into the x goes the 4, into the y goes that 5. Does that make more sense? And that obviously then goes 3 plus 4 plus 5 equals 12, as we see over there in very, very little writing. Does that now make a little bit more sense to people? Because I think the next part of this might be a little confusing if this doesn't make a lot of sense. So again, I'm gonna pause a second for questions. By the way, is everyone still reasonably interested in this? Is everybody still following me as well? Look Ironics, I hope I've pronounced that right. Thank you for the follow. Much appreciated. I don't know if the follow alerts come up because I haven't looked properly. Minxie Rose, the bit that's throwing you is the ABC and the X and Y. Algebra tells you that they're different values. Forget algebra at the moment. A, B, C, X and Y are slots for numbers to go into. So that 3 goes into that A slot. That X goes into that slot B. literally, that A has to equal that A, that B has to equal that B, and that C has to equal that C. They're passed in like that. So we're passing in 3x and y. So we're setting A equal... What we're essentially doing for basic maths, what that call is doing is going, let's let A equal 3, let B equal x, let C equal y, and then it's doing A plus B plus C. Substituting values in, we're letting A equal 3. Plus, we've let B now equal x, and we've let C equal y. So that's the actual sum it's doing. Does that make more sense? Ancient Cody has got this. Hoping that makes more sense. So yeah, okay, that makes more sense. Excellent. So let me do something here. I'm going to get rid of that x and y, and I'm going to get rid of that x and y. So what do we now expect that to do? And this is where I will admit this can get a little bit more confusing. Let me make sure that it does what we think. So let's run it all in interactive again. And it comes out with 12. So I haven't changed the results. But hang on, add to 3 is being called with 2 arguments, and we haven't passed any. We haven't said we need any arguments. So what's going on? You know, if I had the whole thing, why is it so? Let's go and have another go into the screen sketch. Let's get the whole thing working again. What we've said in the past is we can partially apply a function. Or if I put that into English, we can pass this fewer parameters than it takes. If we remember that parameters are these parts. So add 3, we've only passed it 1 parameter. So add is now going, oh, what the hell? I don't know what's going on. I know I've got a 3 in my A slot, so A is equal to 3. No one's told me what B is yet. And no one's told me what C is yet. So what it returns is it goes, I'm going to return something that takes 2 parameters. So add 3 of something and something, we haven't given it. So add 3, if we remember from earlier, then returns that function that we saw earlier. So it returns a function that goes 3 plus B plus C. I've given it 2 parameters after D, %D. We're not looking at this part. We are actually, let's ignore that for now. We're looking at this bit here. The fact that we've said we're defining a value called add to 3 that is add 3. Actually, we are looking at that part to some degree. We've given it 2 parameters there, but this doesn't say it wants any parameters because that is actually the name of the function. That is just, how do I explain this? Let's go back. That is a function that takes 2 parameters. We haven't told it takes 2 parameters, but F# knows that it has to take 2. Because add takes 3 parameters. We've given it one of those 3, so it knows it's got 2 more to pick up. So F# knows that that needs 2 parameters to drop into there to do its job. We can just give it one of those parameters and return another function that takes 1 parameter. So remember the function we wrote earlier that was quite long and indented, that was three one-parameter functions. That is why we don't. This is why we don't have to do that in F# like you would in another programming language, as F# knows that that is three one-parameter functions and is not a single function. I know this has been a very garbled explanation, for which I apologise. Does it make any semblance of sense? Again, I'm going to pause here for questions. This is, again, a very important topic in functional programming. This is that important that it is coffee o'clock. In fact, I am thinking of taking a 5-minute break right now. I'm going to go back to the... Actually, I'm going to leave... No, I'm not going to leave this on screen. I'm going to go back to the prerequisite screen. I'm going to take a, let's say, 3-minute break. So let's go to there. Screen, sorry. Actually, just before we do, I'm on the full screen one. Let's go. Oh, no, you can hear me on this one. Cool. So for anyone that hasn't caught up or hasn't got these things downloaded, please go and do that. I'm going to have, about a 3 to 4 minute break. Then we'll come back and have a look at something a little bit more useful and maybe write a program rather than just execute things in the interpreter. Back soon. Hi everyone, I'm back now. It's time to come clean. There's something that I have been slightly trying to avoid up until now, and now we can't. We're going to actually write a program. Until now we've been scripting and learning F# just through a little bit of a script. We're now going to go a little bit further and write a program. For those in Visual Studio Code, you will have a plus button next to your F# interactive button, next to your F# interactive drop down. If you click that, you will either get Windows PowerShell, copyright Microsoft, or you'll get the normal Windows command line. What I'm about to do will work in both. If you can't get this bit to work, let me know and I will look into it. But what I want you to do is create a new F# project. Let's get this on the ball. So we go .NET like that. Create. No, not create. Sorry. .NET new console-lang equals F#. So it is exactly, in fact let's zoom in a bit more, it is exactly that to create a new F# project. No, I've messed up. I have messed up. Do not do that yet. Make a directory first called calculator. This is how often I do this. We're making calculator as a directory. We're then going to cd into it. And then, what I said before, yeah, don't ever press enter until I have, just in case I make the mess up. .NET new console-lang equals F#. And then when we press enter on that, once we are in calculator, so if anyone needs a second or two to catch up, make the calculator directory, cd into it, and then run this command. In fact, I'm going to put that in chat. Let's make this a little bit easy for everyone. And remember, if you haven't got either Windows PowerShell or the normal command prompt up, it's that button there. So we want to do that, followed by cd calculator, and then this bit of nonsense that's going in the chat now. And then I'm going to press enter on mine. It's going to do some setting up. And it's done. So, can everyone let me know once they've done that, please? Because I really do not want to run ahead of people. This is very, very important that I don't race ahead of you guys. Because, you know, this is your stream, this is your opportunity, as all these streams are, to ask questions, to get the help that you need, and to really drill down and make sure you understand this. While the other streams I might go a little bit faster, these Friday streams are dedicated to those of you who wish to learn, who want to learn from scratch, and hopefully we will essentially have a video series tutorials going from the basics up to a little bit more. Minxie Rose, you've got things to do. We'll catch up on the VOD. Okay, you enjoy the things that you've got to do. Hopefully they're good fun to do. And we will have a look on the VOD. EdgarDev86, can I explain the concept of namespaces and modules? We will be doing so very, very soon. It's almost as if you've read my mind. So, we've got a new project. And if we go File, Open Folder, go to wherever it was that you put your things. Dishes are never fun. So in here it was C, users, stream user, calculator. So we'll open that folder. I'm not going to save what we've done. And we have an fsproj file we don't really care about, and a program file. Right, now we've got to start looking at namespaces and modules to some degree. Because the first thing, this file has a little bit more in than we're used to. It has, oh, in fact, why don't I go into screen sketch mode again. So it has open system. That is saying that somewhere there is a namespace or a module, F# doesn't care, called system, and it's saying let's have a look at system. So instead of having to go system dot whatever, we don't need that, because this file knows that anything could be in system. And then we get this in the square bracket and angle brackets. That syntax there denotes that this is an attribute. That is applied to the next declaration or whatever after it. Thank you for the follow. Thank you for the follow, Thackum5. I need to be careful how I say that. Please post in chat, tell us who you are, where you're from, what your life story is, what you're interested in with F#. Probably not your full life story though, we don't need that. And if everyone could welcome in Thackum5, I would most appreciate it, please and thank you. So we've got an attribute here. That says that whatever follows it, tag it with this. In this case, the attribute is called entry point. Entry point is a way of telling .NET, or a way of telling the runtime, exactly what function to run to start with. Thank you very much for the follow, EdgarDev86. Again, if we can have some thank yous in chat and some full-on welcome, that would be wonderful, please and thank you. So then, we've got a function declaration. This is let main argv. So main, actually in F# it doesn't matter what that name is. By tradition it's called main. If we want to call that Bob, we could. Because instead of looking for a function called name, we're looking for that entry point. argv. Now it comes up there that it's a string with a brace of brackets after it. So argv is a carryover from the C days. I wouldn't call it that, I would call it args probably. You know when you run a program from the command line and you say, oh I don't know. Well, we've done it, haven't we? We have just done mkdir calculator. So what we've done is mkdir was the program name, and calculator we passed to it as an argument. Now that, if this program were called makedir, would have been passed in to there. And it's string bracket bracket. String is simply just text. Nothing more. The bracket bracket syntax tells us it's an array. So if we'd said something else as well, boo, bar, whatever, all of those would individually have been passed into argv as elements of the array. The reason that it's dim in Visual Studio Code, we're not using it. We are required to accept it, but we are not using it. So carrying on down here, printfn hello world from F#. Again, function, argument. We've already looked into that. We know what printfn does. To recap, it just spits something to the screen. And then that 0 I don't know if I've explicitly said this, but I think we've touched on it. The last expression in a function is what gets returned. 0 tells the OS, so Windows, Linux or whatever, that we're fine. That we ran with no errors. If we were to return a 1 or any other number, that would come out as an error code. Things like Linux, Mac OS, whatever, would see that as an error code and would respond as such. And again, I missed out that bit at the top. So you got a double slash there. Anything after a double slash is a commenting code. So the F# compiler doesn't look at it. It doesn't care what you put after a double slash. There's another way of commenting things, which is a normal bracket and a star, then a star and a normal bracket again. Anything in here is treated as a comment and is not code. There used to be a big movement around commenting your code. There is now probably an even bigger movement saying that if you need to comment your code, you're not doing it right. I'm going to leave that up to people's discretion. That's not what this stream's about. I'm not here to impart my views on this. So, out of there we go. We now have a program. This is rather exciting. So, we need to run this to make sure it works. So, if we go debug, start debugging, or press F5, in the output, it's in a terminal, it's doing a load of downloady stuff, and wow, that's a huge thing. And now it's going to ask us up here what environment we're working in. We're not working in Node.js, we are working in .NET Core. Well, let's say .NET Core. And it's given us this thing called launch.json. Now, for now, I am going to shrink my font size down to about that, I think. Can everybody still read what I've got on the screen? I'm just making sure that people, if they're watching in a window and whatever, can still read what we're doing. This launch.json file, we could look through. We're not going to. We don't care. This output here, this is just a simple install of a few bits and bobs that we need. So let's press F5 again, or go to debug, start debugging. And it said could not find the task build. So let's tell it to configure that task and create it from a template, .NET Core. Cool. We don't really care about what that is. So we've now had to create two files. This is all for .NET, for Visual Studio Code. In Visual Studio itself, if we were in there, what we would have done, and by the way, we probably ought to do this to show, the equivalent in here, File, New Project. Go to Visual F#, .NET Core, Console App. Call it Calculator. Click OK. And there's a slight tweak in here. We don't want to just run. We don't want to use the F5 option. In Visual Studio, again, it's come up with exactly the same code. We want to use Control F5. And Visual Studio itself doesn't make us go through what we've just gone through. And it gives us this output. Hello world from F#, press any key to continue. If you just press F5 by mistake, or you can go debug, start without debugging. If you just debug, it will just flash up and then go away. The reason is we've set no breakpoints, so it kills the program before we've had chance to look at what's on the console. So it went, okay, I'm going to print hello world from F# and now I'm going to exit. If we run without debugging, it does pause it there for us. Back into Visual Studio Code though, we have got a launch.json and a tasks.json. Let's have another go at starting debugging. Wow, rip, headphone users. Let's have a go at starting debugging again. Debug, start debugging. This time it should work. Come on. This is why I wanted to install this from scratch for us. And we have another problem. It doesn't exist. What's it moaning about? Well, it's actually moaning about this line here, line 12. If you can see, launch.json for me didn't tell us what we were doing. So it said bin debug, and it put the inserts there instead of filling it in for us. That's rather annoying. So if we look over here in our file panel, bin debug, net core app 2.1. In fact, let's zoom in. Whoa, let's zoom into the right place though, please, people. Let's go to bin debug, yeah. Then it goes net core app 2.1. Then it goes calculator.dll. Cool. So we know that it wants net core app 2.1 put in there. And it wants calculator put in there. Save that with Control S. Incidentally, this we want in the .NET Core Launch console. This .NET Core Launch web thing that it's put there for us, really don't need. So let's get rid of that. The launch.json now is much smaller. That's good. Let's have another go at the debugging. Debug, start debugging. This time, it does exactly what we said and gives us that. Gives us other debug information like the code 0 it exited with. That code 0 that it exited with is what we told it to exit with. So it got that right as well. And it's told us what we've loaded up and, you know, the fact that we're only allowed to use the .NET Core debugger with Visual Studio Code, Visual Studio, or Visual Studio for Mac. That's fine. We're doing exactly that. We now have a program. But what programs work without us having any... what programs will work for us if we don't get to input something in? That's a pretty useless program if it can't take input. So let's modify this to take some input. Let's say that it asks us our name. What is your name? And then we want to take some input, and then we need to print out hello, whatever that person's name is. So we've got to work out what to put there and what to put there. Okay, let's see what we want to put there. Well, I want to read something from the console. That kind of helps us out on what we need. We need something from the console. So start typing console, and Visual Studio Code again is very nice and brings up all the things we could use. Console. And we want to read a line. We want a line of text. And we need brackets after it. This is where things are going to get confusing. .NET methods, which is what we've just called readline, are not F# functions. They are different things, and they have to be treated differently. So I don't know if you can do that, but readline takes unit. In fact, let's show it. Takes unit, spits out a string. Remember that arrow syntax. So console.readline, we've got to give it unit. Great. But it's moaning. It's saying that the result of this expression has type string and is implicitly ignored. Consider using ignore to discard it, or this value explicitly, or let to bind the result to a name. And it gives us examples of how to do both. Now, if we're reading a line of text, we want that, don't we? Otherwise, we would be, we wouldn't bother. So, like how Word gives you a green underline for grammatical errors, this is only really a grammatical error. It's not a real error, it's not an error, it's something that we might want to look at. And also, this Problems tab here tells us the same. Well, let's go back to the Debug Console. Well, we've said we want someone's name, don't we? And that's the text that's coming back. So let's let the name equal that. And if we hover over name, again it says val name : string. That's saying that name is a value whose type is string. As we remember, string is text. Great, so we need to find a way of spitting that name out here. Now, do we remember that we can give format specifiers? We used %d for an integer, for a number. We used %f when we were using decimal pointed numbers, when we were using floating points. If we're using strings, we can give it a %s. But just %s isn't enough. And again, F# is really helpful. It says to us that this expression is a function value, i.e. it's missing arguments. Its type is string to unit. So what we've got there is actually a function that takes a string and prints hello and that string and then gives out a unit, gives nothing out. So we might as well pass a string to it. What string are we going to pass? We want to pass that person's name, don't we? And now we have no red underlines, so this will compile. We have no green underlines, so we haven't even got any warnings. So let's save this. File save or Control S. And we'll have another crack at running it. Again, if you're in Visual Studio Full, Control F5. If you're not in Visual Studio Full, if you're in Visual Studio Code, which I'm in, you can just press F5. It will say building down at the bottom left and running. And it's now asked me what is my name. My name is Gareth. I've told it my name's Gareth. And I don't know why this isn't playing nicely now. Do we need to go into the terminal? That's rather annoying. That hasn't worked. Why has that not worked in here? Let's do Control F5 and see what happens. What is your name has again come up? Does this work in the Debug Console? Okay, I'm now getting an error that I don't understand. Is it that I've put a space that there shouldn't be one? Let's find out. Let's see if I do that instead, if this works. Go back into debugs. It's going to build, it's going to run. I'm then going to type that in again. No. Right, this is where we get to learn about how software developers in the trade actually do things. Let's Google it with Bing. Console.readline Visual Studio Code Debug Console. We're now actually going into something that I possibly should have done something about. Okay, the Debug Console window does not... this is an actual error by the looks of it in VS Code. We're in OmniSharp. This is output only. So we need to set the console property to external terminal. Internal terminal should work as well. Okay, there is something that we need to do in Visual Studio Code to make this work. we can't use this debugging console, which is default. So again, I'm glad I've done this on stream, because otherwise I would have made this change and not understood why this doesn't work for people. Let's go File and Preferences, Settings. And type in Search Settings up here, Console. And down here, where is the setting? It's not that one. Let me have another quick look here. It is the console property to external terminal, internal terminal. Should work as well. Ah, no, I am wrong. We have another problem. It is in launch.json. I think. Is it? Yeah. So ignore what I just said. We don't have to go into the settings. We have to... I'm not used to using Visual Studio Code, by the way. I know it's the easier one. So console, internal console isn't working. Let's try, as they suggest, external console. No. Oh, hang on. Valid values. Internal console was the one we were using. That didn't work. Integrated terminal or external terminal. We go integrated terminal. So I'm going to paste a little snippet. I'm going to paste this line into chat for everybody. The line that I am putting into chat now is what I am suggesting that we use instead of the line console : internal console. That is in the launch.json file, which is under your .vs code directory in your project. This is kind of why I'm glad that we're going through all this on stream. As much as we're having problems and I'm falling down a few times, we at least have a record of the things that we've done to set this up. Now, assuming that this works, if I press F5, it should go into the terminal, which it has, and run. We are now in there. If it goes back to the debug console, which it did for me, just click terminal. Visual Studio, full people. I'm just going to quickly copy this in, just before I forget. So, what is your name? Gareth. The code was absolutely correct and spat out hello Gareth. People in Visual Studio, full. I've put the same program in there for you. Control F5 will bring up a... I'm going to call it the DOS box. I know it isn't, but it might as well be. Again, if I put Gareth in there, it works, and then press any key to continue to kill the application. So we've demonstrated a program running in both VS Code and Visual Studio. We have got an understanding of functions. Let's try something. This isn't much of a calculator yet. In fact, it really isn't a calculator at all. So you know that add function we had before, which looked something like let add a b equal a plus b. And again, it shows that it's an int to an int to an int. So let's have input a number. Please, let's use manners. Let norm1 equal console read line. If we copy that and just do modifications, input another number, please, and then we'll print fn %f, because I'm going to let people use decimal points, plus %f equals %f. Now, how lovely would it be? Oh, and num1 we can't use twice, so let's have num1 and num2. Well, let's say that we're going to use num1, num2, and add num1 to num2. This sounds utterly lovely, doesn't it? However, we have little red squigglies, so let's have a look at the problems. The type string is not compatible with any of the types float, float32, decimal, arising from the use of a printf style format string. Now, I said a minute ago that we wanted decimals. So what's gone wrong? Well, if we hover over this read line, it says that it's unit to string, so it takes nothing, spits out a string. That's not really good to us, is it? We wanted this to be a float. What are we going to do about that? Well, if we say let num1, instead of having that as num1, let's have that as text1, and then we go let num1 equal float dot parse float. Oddly enough, I'm not entirely sure here. What does float itself do? Let's click on that and say it converts the argument to 64-bit float, but it's only a conversion for numbers. For strings, the input is converted using double dot parse. Oh, cool. So if we say float of text1 there, then that error disappears. Excellent. So we know how to convert things to floating point numbers. So let's again have that as text2, and we'll let num2 equal the floating point value of text2. Ah, we've run out of errors. That must mean something's good. That must mean that we can do something here. Let's give it a little run, shall we? And pressed F5. Again, proper Visual Studio, Control F5. I say proper Visual Studio. No, Visual Studio Community, Control F5. And again, if we're coming up with the Debug Console, I'm going to move to the terminal. It's asking me to input a number. 0.2. That's a good number. We know that one. Input another number, please. 1.5. And it said 0.2 plus 1.5 is 1.7. That's not a calculator yet, but we're getting somewhere. We are actually getting something. But have you noticed that we've done almost the same thing twice? Doesn't that seem silly? Doesn't that seem like a lot of work? You know, we've literally just gone and done the same thing twice. So would it not be worth us, because we are programmers and we are not, we're a little bit idle as programmers. We don't like doing work. So what do those 3 lines of code do? Well, conceptually, we are asking for a floating point number. Let's write a function. Let ask for float, because that's what we're doing, asking for a floating point number. What's different between these? The text that we're asking people for. So we need to, yeah, I mean, we're developers. We like coffee, not work, Minxie Rose. You are absolutely correct there. So we're asking for a float. So we have a different prompt for each one. So let's take in a prompt. Let's learn how to spell as well. We'll make that equal to, well, let's do a bit of copy and pasting because I don't like doing work. So what are we doing now? Well, we're asking them for the prompt. So instead of that, input a number, please. Stick prompt there. Cool. And let the text, well, we don't need to use a number then. So we'll let the text input equal that, console.readline. Copy that to there. And we don't need to let anything equal that. We just need to return it, don't we? Now, this is interesting because it's saying that it takes a printf.textwriter format of unit and spits out a float. I thought it took a string. Now, this is a little bit of magic in how printf and printfm work and how we can do static type checking on them. They are a little bit special with conversions. Let's see if this works though. By the way, if this doesn't work right, we have a trick, we can do conversions. So now what we're saying is, printfn add input number please, do that. Well, surely the number should be equal to, well, let's ask for float and pass it, please enter a number. Okay, number 2. By the way, if you're wondering what I've just done there to duplicate the line, Control C if you've got nothing selected, and this works in Notepad, in everything on Windows that I know to. Control C if you've got nothing selected, copies the whole line, and then Control V pastes the whole line. So I just did Control C followed by Control V immediately, and that duplicated the line. So we'll let in num2. Well, we're asking for a float, please enter another number. And that means we don't need any of that malarkey. And this program, this is what I was saying about self-documenting programs and not needing comments. I would hope that this explains itself. It's saying let the first number equal, we're going to ask the user for the float, and we're going to give them that prompt. Same for the second number, ask the user for another float, give them that prompt. And then it's printing out the result. So in true programmer style, we've done more than 30 seconds of work. We've got no compile errors. It must be time to try it. So let's give it a go. I've gone into the debugger again in Visual Studio Community, Enterprise, whichever version you have with work. Control F5. We go into the terminal. Please enter a number. 26. Please enter another number. 16. And it tells us that 26 plus 16 is 42. So it knows the answer. That is good. Which, considering that we've now got something resembling, well, we've now got a program. Let's do a quick recap and a quick Q&A. So if you have any questions that you've been saving for a dedicated Q&A block, you're in luck. There is one now if you would like one. But just to recap what we have done with this program. In fact, we can go into Drury mode again, because I've now decided it's called Drury mode. What we did first is we made sure that we knew how to print things to the console. So we did that print function stuff. Then we remembered that we know how to add numbers together. At that point, we realised that if we got positional arguments there, so that %f goes to that num1. This %f here goes to that num2. And we learned that, let's have another fetching colour. Let's have a fetching beige. This %f goes to the result of that. So that's something that we learned. Possibly I didn't state that, but that's something that we learned just through experimentation. So that there is the third one. The red one was there, the yellow one was there, to save me keeping changing colours on this tablet. I don't have hotkeys to do that yet. So we then did that, but we had lines of text similar to this, there and there, and we realised we were doing the same thing twice. And as programmers, we do not like doing that. So we pulled all that text out into its own, all that code out into its own function. At which point we realise that that prompt isn't necessarily a string, it's some weird type. But that means that we can statically type check that we are getting this right. And we're calling that function twice. Now, incidentally, this is not a pure function. The reason this is not pure? That relies on state from the outside world. So, this means it is not pure. By the way, that proves that it isn't pure either, because that changes the state of the world. A pure function cannot do either of those. That is getting ahead of ourselves though. That's probably something to look at next week. But just remember, if you see a read line or a printfn, we are again not pure. This is a function that changes or requires the state of the world to do something. Again, because we have that printfn there, this main function is not pure. You cannot create a program out of only pure functions reasonably. A language called Haskell wants to try and prove me wrong by using some weird daft trickery that I am not going to mention even the name of now. For the name of that trickery scares people. However, does being pure matter? Minxie Rose, being pure is a wonderful thing, because being pure means that we can call it any amount of times that we like, and it will not do anything different. Incidentally, this function here is pure. And the reason is, you can call add 5, 7, and it will return the value 12. You call add 5, 7 again, it'll return the value 12 again. It doesn't change anything in the outside world, it doesn't print anything to the console, it doesn't take anything in from the console. It doesn't require anything from the console. So purity is interesting. Just a little look ahead and a little hint to where we're going next. The idea is that you need to keep impure and pure separate. You need a barrier between those. Impure can call pure. If an impure function calls a pure function, that is allowed. If a pure function, however, tries to call an impure function, that is not. Because at that point, that impure function pollutes the purity of that, and that then suddenly becomes impure. And the more of your program that's pure, the more easy it is to test in an automated fashion. Again, that's something that we will come on to in a few weeks, but just the idea of purity and impurity is something that we possibly ought to discuss on another stream soon. I'm conscious of time. In the UK, people are going to be wanting at the very minimum a mug of tea, probably some dinner soon. Does it still work? Asked Minxie Rose. Yes. Muddling pure and impure, you will get stuff that works. You will not get a particularly pleasant architecture. You will get everything muddled, and your code will not look nice. Your code will be hard to read. If you can keep them separate, you will tend to get, and I say tend to get because someone will prove me wrong, and they will prove that you can make it horrible even so. But if you separate pure and impure, that is a very good pattern and a good way of making your code work nicely. If you look here, we've got code in smaller chunks. We've got that chunk that is impure. We've got that chunk that is impure. But we have a little chunk there that is pure. Which means to unit test that, all I have to do is conceptually say, okay, add a b. I'm going to throw 3 and 4 into that function and 7 should come out. And I can do that as many times as I want and I'll get the same result. So I can tell something that A and B can, as long as they're numbers, we can add them up, we can do tests on that. This, if I said, okay, so I want to prove that that the function ask for float works, I can provide it any prompt I want, but then using the return value of that and the return value only, I cannot verify that it printed to the console, and I cannot verify that it got what we needed. I also cannot verify that it works for people who are a little bit malicious. And by that, let me demonstrate something. I'm going to run this program again. So F5 or Control F5, let it rebuild and run. So we'll go into the terminal. Please enter a number. Now, I'm not a nice person, or I think, well, my number keys don't work, so I'm going to enter the number 3. Oh, big red came up. That we don't necessarily need to understand yet, but that is a runtime error. And what it's saying is float has taken that number 3 and said, this is text. Right, this is not a number, this is text. I don't know what to do, and panicked. So at some point we're going to have to learn how to deal with that. We're going to have to deal with users. And this is why a lot of programs have problems, is we have programmers can't always think of the things that users are going to do. But with a pure function, I could run a test that gives that the wrong things, and when it comes back and says no, I can fix that, give it the wrong things again, and it will then come back and say, okay, I now understand what's happening. So we can catch bugs in our program as much as, yeah, I mean, Minxie Rose, you're saying user error, but, you know, as a user, I would not want my computer crashing or my program crashing because I made a mistake. I'd like it to tell me nicely that it's made a mistake and then remain graceful. So, just now that we're back from that tangent, what have we done today? We've written a program where we can add 2 numbers together that the user provides to us, and as long as the user provides the numbers to us in a format that we understand, we can add them together and give them the sum on the output. We have the beginnings of a calculator, people. With that, anyone that doesn't understand it, please post in the Discord or ask questions now. There is a link to the Discord. This code is going to be posted in the Discord immediately after this stream. It will be in the Friday category in one of the channels in there. Again, please follow me on Twitter. You'll get advanced stream notifications there. You'll get them on the Discord as well in the announcements channel. Have a look if you're really interested in what more advanced F# code looks like. Then there's a link to the GitHub there for those that understand version control, that understand Twitch. This is the application that we're developing on the rest of the streams. I want to say, because we all want to learn F#, that's the official excuse that I'm giving. The unofficial excuse is I'm too tight to spend 130 odd quid on a Stream Deck, and I want a Stream Deck, so I'm making one using a spare Android tablet and the fact that all the APIs are nice and open. APIs application programming interface, ways I can hook into other things. So if you want to watch that stream to have a look at the software development process on the Tuesday streams or the Sunday streams, please drop in. If you've got any questions, ask them there as well. We are, as much as they are slightly more advanced, they are still for learning. And if you want to try and follow along with those, they are much faster paced than this. They'll give you a really good, I think, good insight into how software developers work, how we think. I know that we get a couple of regulars in there who are way more advanced than myself, so you'll get to see me fail quite a lot as well, if that's kind of interesting to you. With that, as I hear no questions at the moment, I think we should probably go and do a little raid. So let me have a look at who's streaming right now. Directory following is what I want in this browser. If anyone has anyone that they would like to follow, that they'd like to raid, who's doing programming style stuff, please do so. Let me know. In fact, I've got someone I'm going to raid right now. I think we're going to raid a game developer. So let me go into his channel now. He's using another .NET language called C#. He's in Visual Studio. He's using a game engine called Unity that supports C#. A lot of things are similar. You'll see some similar concepts, and you'll get to see how games are developed. So let me just kick that raid off. And also, when we go across there, you'll get to take part in a very fun sort of Twitch extension-y game and go on dungeon raids. So with that, let's get across there, let's announce our raid, let's go in loud and proud, because he really is a fantastic streamer.